Hi, this is Roger from Labs, and today I want to introduce you to our new set of 4 different antenna tuners designed for tuning resonant magnetic antennas, either with a variable plastic film capacitor as in the 2 lower ones, or with a set of 4 varactor diodes. Let me first explain what the 4 models have in common. As you might notice, they all look quite similar. And then we'll go to into the details of each model. Well, you see on the left side we have, that's where the antenna is applied to. We have 2 professional binding posts, so you can use them in multiple ways. They have on the one side standard 4mm banana plugs, and you can plug in, for example, one of our Spiderweb antennas. They directly fit inside. Or you can also apply antennas here with a wire. The binding posts have a hole in the middle, and you can put wire up to 1mm diameter through them and fix them by screwing them, or you can put the wire on the side and just clamp it down by screwing the upper screw down. So that's where the antenna is fixed to. Of course, as you might know, these AM antenna tuners are only designed and useful for tuning resonant magnetic antennas like standard loopstick or Ferrite-Rod antennas. And you can also use such a loop antenna made out of copper tubing. We have the standard 19mm distance between the 2 binding posts, so also a lot of antique antennas immediately fit, so that's quite versatile how the antenna can be fixed or applied to the antenna tuner. Then on the output side we have 2 unisolated banana plugs in parallel to a BNC jack. The output impedance is not standard 50 ohms. That's due to the little FET here, the little transistor, which has a dynamic impedance of around 300 ohms. And so you can use the outputs either with the 4mm banana jacks, or you directly put a BNC cable here. You might wonder what is the battery here for, and what is it used for, especially here in our basically passive antenna tuner with the variable capacitor, which basically needs no power. Well, the reason is we wanted to buffer the signal without introducing any load to the resonant circuit. You might know the inductance of the antenna that you put here, and the capacitance of either the variable capacitor or the varactor diodes. They built a tank circuit, a resonant tank circuit, and to get the highest possible Q factor, we undertook several measures, not only that all copper traces are very thick so that you get a low impedance path to the tuning capacitor, but also for not loading the tank circuit, the LC resonant circuit, we decided just to buffer the antenna signal with a little JFET, and these JFETs simply don't have a low enough impedance on their outputs. So that's the reason why we have around 300 ohm dynamical output impedance. So, but of course, the buffer transistor needs some power to work, and we decided for two ways to apply power. You can either use this 12 volt alkaline battery for power. We minimized the power consumption to something around 1.5 milliamps, out of which 1 milliamp is drawn by the buffer transistor, and around 300 to 500 microamps are used for the LED. We used a high efficiency LED so that we could drive it sufficiently bright with only 300 microamps of operating current. And this is basically the same on all four. The LED also serves as a low bat indicator. When it doesn't shine anymore or not bright enough, then you should change the battery. The battery will last for at least 20 hours continuously supplying current. But if you want to operate this for longer times or don't want to change the battery all the time, we also have an external power supply where you can apply any standard 12 volt DC input. So that's basically what they all have in common. And now let's take a look at the differences between the four units. So let's start with the simplest and cheapest model. You might notice two things here with the two little sliding switches. First of all, we made an error in the layout that the designation of power and off is reversed. Of course, we will correct this in the next version. Anyway, we will apply a note to each antenna tuner that you should watch out that here the designation is reversed. And the second thing you might notice, this one is switchable from 50 picofarads final capacity to 500 picofarad final capacity. These are not the exact values. The exact values we will give you in the data sheet. It's just because of the round numbers. The reason is, if we take a look how it looks inside, this is our variable capacitor of the plastic film type, and it has all in all four packages of capacitors that can be varied, and we have two of them each parallel, so that one side gives around 500 picofarad, the other side gives around 50. In fact, it's a little bit more. And you might notice these four little capacitance trimmers. We factory set them all to minimum capacitance, but you can, if you wish, add up to 40 picofarads to each section. But this of course goes from, or this applies to as well the lowest capacitance if you turn the knob to the right, and to the highest capacitance. So you can vary a little bit the starting and final capacity of the variable capacitor. And well, not much to see below. What else can we say? You have 180 degrees of rotation, and we used the biggest knob that we have available, and that still fits. So you have a relatively, due to the big diameter of the knob, you have a relatively good control of the frequency. And what should be mentioned, in the 500 picofarads setting, you have a capacitance range of around 15 to 1. That means that you can tune frequencies, or a frequency range in the in this setting of the switch with the higher capacitance of more than 1 to 3, so you can tune the whole AM frequency range, which goes from around 500 kilohertz to, depending on the region where you live, 1500, 1600 or even 1700 kilohertz. So that's quite a nice feature, that you have a very large capacitance range. The range in the lower setting is much smaller, and this is more or less useful for the shortwave stations. By the way, we designed the antenna tuner to work from a few hertz up to 30 megahertz. That means it's not only intended and useful for tuning radio stations in the long wave, medium wave and short wave range, but also for ultra low frequencies, and the other designation is, I think, ELF, extra or extremely low frequency. So this is really very versatile, because the frequency range is really quite large, and this is valid for all four models that we supply. Now there's one little disadvantage of this first model. Although you have a big knob and a relatively fine control of the capacitance and that way of the tuned frequency, all the plastic film variable capacitors are what's so-called capacitance linear. That means that the frequency, which is always the square root or proportional to the square root of the capacitance, that at one end of the tuning of the setting or of the tuning range, the frequencies are a little bit compressed. So we also made the direction just as you are used to. If you turn it clockwise, the frequency goes up. So that's the what you naturally would think by turning a knob clockwise, that you get to the higher frequencies. But you will notice that if you really tune, for example, in the AM range, that starting around here at 2/3 of the way, the frequency range is quite compressed, and that it becomes more and more difficult to fine-tune a station. And that's why we decided as the second model to use the same tuning unit, but to supply it with a 1 to 6 gear reduction knob. And that way you not only have only 180 degrees of tuning range for the knob, but now you have 3 whole turns for really fine-tuning, also at the end range where the frequencies are a bit compressed. So these are the first two models. Electrically, they are absolutely the same. The difference is here you have a big knob, and here you have this 1 to 6 gear reduction knob. So, and finally, let's take a look at the other two models, which use varactor-diodes. They basically are also electrically the same. The only difference is the kind of varactor diode we used. In this model here, which you perhaps can read, is also going up to 500 picofarads tuning range. We use a high capacitance varactor diode, and in the second model, which only differs by the used varactor diode, this one goes to around 50 picofarads. Also with the same difference as we had with the plastic film capacitors. Here you have a capacitance range of at least 1 to 16, which means the tunable frequency range is nearly 1 to 4, which means the lowest setting in frequency you can achieve is 4 times lower than the highest frequency setting. And as in the other models, here the 50 picofarad version has a lower relation between highest capacitance setting when the knob is turned fully to the left to the lowest capacitance range. For the exact data, I will give you a link down below to the data sheets where the typical values of capacitance range are given. But what you not can recognize at first sight, we use a 10-turn pot. You can see it here if we look down below. And as you might know, a 10-turn pot has, as the name suggests, 10 turns, 10 whole turns, so that you can extremely fine-tune the capacitance and that way the frequency. And that is really quite a nice feature, I think. In the first models, we will also use this in quite beautiful and big knobs. In later versions, we'll probably change to smaller knobs because, well, this is a special edition, the first production models. And, well, not much more to say. You can see there's a little bit more of active and passive components. That is because from the 12 volts supplied from the alkaline battery, we use a low dropout linear regulator to generate a stabilized 8 volts for the as supply voltage for the varactors. And that way we get an extremely stable setting of the tuned capacitance and that way the tuned frequency. So I hope you find some uses for our new AM antenna tuner. They should correctly be called resonant magnetic antenna tuners, because you can not only use them for AM radio reception, but there are a lot of interesting signals below the AM radio range. Like you can listen to submarines and time signal transmitters, and there are a lot of interesting signals. And this is we made it so versatile that you can really use it for every frequency up to 30 megahertz, as I already mentioned. And we made every effort just to get the highest possible Q factor, so that the achievable Q factor you get from the antenna tuners is not limited by this tuning unit, but usually it will be limited by the losses, ohmic losses and skin effect and whatever of your reception coil or whatever you use for reception, for radio or signal reception. So that was it for a short introduction. I hope you liked it, and see you next time here at Kanka Labs. Bye from Roger. Bye from Kanka Labs.